Oh, hi ma'am. Good evening. So I developed a project agentic RAG chatbot multi-format document QA using model context protocols. So before I explaining about the code, giving the demo of project app, I want to make sure of one thing that, ma'am, this is my new laptop, so I haven't set up the project environment yet. The code requires certain Python libraries, environment configurations, and databases. So I'm in the process of setting it up. I'll install it the required packages, configure the environment variables like API keys and databases URLs, and ensure everything is connected correctly. Once the setup is complete, I will be able to run the code, demonstrate the full functionality. Since this is a new laptop, it doesn't have the necessary dependencies, so I hope you understand everything. Uh, but I'll explain the system architecture flow. So, so here is my system architecture. The architecture of this project is designed for scalability and efficiency. The main components are user interface, backend application, AI model, file storage, and a database. So the user interface where users upload files and ask questions, this built using technologies like Streamlit or React. The backend where the API logic resides, it handles request, processes data, and communicates with the AI model. The AI model, which is responsible for understanding and retrieving information, it uses embedding techniques like uh, FAISS or Pinecone, and inference tools like OpenAI or Hugging Face. And the file storage, which securely stores uploaded documents either on the cloud like AWS S3 or locally depending on the setup. And the last one, the database where processed information and metadata are stored for retrieval and querying. So now I'm giving the explanation for data flow. This process begins where a user uploads a file. The app extracts the text from the file and breaks it into smaller parts. These parts are then embedded into a vectory database for fast search. When a user asks a question, the app searches through the embedded content and finds the most relevant parts. The AI model processes these results and generates an accurate answer. Then the response is sent back to the user in real time, providing seamless interactions. So, and the technology is used. Wait a minute, ma'am. Sorry. I'll open my readme.md. So here the technologies are used. The front end is built using Streamlit for simplicity and responsiveness. The backend is handled using Flask or Fast API depending on the environment. The AI processing is done using OpenAI and Hugging Face. Models for embedding and question answering. This is used to store the vector data efficiently. Cloud storage options like AWS S3 are used for storing files securely, while SQLite or PostgreSQL can be used for storing metadata and query history. And I want to explain about. I'll explain about error handling or fallback mechanisms. Uh, the system also manages unsupported files or missing data gracefully. If an unsupported file is uploaded, the user is informed with a clear error message. Similarly, if no relevant content is found during querying, the app provides suggestions or prompts to refine the question. Mm, so this is my app.py. Yeah, I want to walk through the code. So now let's go through the code structure briefly. The project folder is organized in a way that makes it easy to understand and maintain. Inside the main folder, these are the subfolders like static and templates, which contain the front end files, styling, and layouts. The main Python files are app.py and utils.py, config.py. So it's app.py handles routes, API endpoints, and serves the request. There are also requirement text. Yeah, here it is. Yeah. Uh, this file lists all the libraries needed to run the project. In app.py, the upload endpoint allows users to upload files, while the query endpoint handles the search request. These are connected to the front end and back end. So the core logic involves handling the file upload, extracting the text content, then embedding it, and then querying the data. The file upload handler reads the file and validates the format and saves it temporarily. The text extraction logic ensures that the content is processed efficiently, and whether from PDFs or slides. The embedding process transforms the text into vectors that can be searched quickly. The query embedding matches user questions with the stored content and fetches the most relevant information. Finally, sorry. Finally, the API is called with this information to generate the answer and then send it back to the users. Uh, so throughout the code, I have added comments that explain each step clearly. This makes it easier for anyone who read the code or anyone who is reviewing out there. So this is about my project. This structure ensures that the project is scalable, secure, and easy to maintain. The code is very clean, well commented, and designed for a seamless user experience while ensuring privacy and accurate information retrieval. So this is about my project, ma'am. This is my retrieval agent.py, and this is our ingestion agent.py, and this is about LLM response agent.py, and this is MCP, and I'll show you my PPT all slides. This is the system architecture and flow. I have walked through the code. App demo I couldn't give this for now because I said you before all the reasons. Maybe if you give me a chance for one day, I'll submit it. So this is how my project works, ma'am. Thank you.